Find the linear approximation of the function g of x, which is equal to the cube root of 1 plus x at a is equal to 0, and use it to approximate the numbers the cube root of 0.95 and the cube root of 1.1. And then we're going to illustrate by graphing g and the tangent line. So the first thing we need to figure out is we know that a is going to represent 0. So if we want to write the linearization of what this is going to look like, it's going to be L of x, which is going to equal g of 0 plus g prime of 0 times x minus 0. So the next thing we want to do is take a look at the function and then take the derivative of that function. So we know that the function is g of x is equal to the cube root of 1 plus x, which we also know is the same thing as 1 plus x to the power of 1/3. And so now we're going to find g prime of x. And so taking a derivative of that, we're going to have 1/3 times 1 plus x. And so that's 1/3 minus 3 over 3, which is negative 2/3. And that's times the derivative of what's inside, which is 1. So therefore, the derivative is going to be 1 over 3 times, we have the cube root of 1 plus x squared. So therefore, that is the derivative of this function. So now what we want to do is we want to evaluate g of 0. So if we plug g of 0, then we're going to get the cube root of 1 plus 0, which is the cube root of 1, which is equal to 1. And if we want to find g prime of 0, well, that's going to equal 1 over 3 times the cube root of 1 plus 0 squared. Well, that's going to be 1/3. 1 squared is 1. The cube root of 1 is 1. So we know that's going to give us 1/3. Okay, now we're going to use the equation from step 1 to plug in our given information. So that is g of 0 plus g prime of 0 times x minus 0. So we know g of 0 is going to be 1 plus g prime of 0 is 1/3 times x minus 0. And therefore L of x is going to be 1/3 x plus 1. So there's the linearization. Okay, so now that we found that, now we want to then approximate the numbers the cube root of 0.95. Okay, so if we have the cube root of 0.95, we know that's the same thing as the cube root of 1 minus or plus negative 0.05. And so therefore, we want to find the linearization when we let x equal negative 0.05, and that's going to equal 1/3 times negative 0.05 plus 1. And so when we go ahead and plug that in, then we get approximately 0.983 with the 3 repeating. And then if we take a look at the cube root of 1.1, well, that's going to equal the cube root of 1 plus 0.1. So we want to find L of 0.1. So that becomes 1/3 times 0.1 plus 1. And that equals 1.03 with the 3 repeating. Okay, now let's graph these functions. So we're going to graph first the function which is g. So g we know is the cube root So we have the cube root of 1 plus x. Okay, and then the linearization function is 1/3 x plus 1 So here we have the graph to confirm our results. Okay, so the green function, this is our function g of x, which is equal to the cube root of 1 plus x. And then the linearization function L of x is equal to 1/3 x plus 1. And you can see that it's tangent and it's above that curve.